When you first look inside an industrial control panel, you see a lot of components, and most of them look confusing. What's the difference between a contactor and a relay? Why does the panel need its own power supply? What does a PLC actually do? If you've ever asked any of those questions, this video is for you. Today we're going to cover the 5 control panel components that confuse beginners the most. By the end of this video, you'll know exactly what each one does, why it's there, and how it fits into the bigger picture. Let's get into it. Welcome back to Panel Design Pro. Number 1, and probably the most confusing one, is the difference between a contactor and a relay. Here's the simple answer. They both do the same basic thing. They use a small electrical signal to switch a larger circuit on and off. The difference is the size of the load they control. A relay controls small loads, things like indicator lights, PLC inputs, or low power control circuits. Relays typically handle up to around 10 to 15 amps. A contactor controls large loads, motors, heaters, large equipment. Contactors can handle anywhere from 9 amps all the way up to hundreds of amps depending on the size. Think of it this way. A relay is like a light switch in your house. It controls something small. A contactor is like the main breaker panel in your house. It controls something much bigger. In a motor starter circuit, the contactor is what actually sends power to the motor. The control circuit, with your start button, stop button, and overload contact, just energizes the contactor coil. The contactor does the heavy lifting. Number 2, the overload relay. This one confuses beginners because they think, wait, don't we already have a circuit breaker? Why do we need an overload relay too? Great question. Here's the difference. A circuit breaker protects the wiring. It trips fast, in milliseconds. When there's a short circuit or a massive overcurrent, it's protecting the cables from catching fire. An overload relay protects the motor. Motors draw more current when they're working hard. If a motor is overloaded, it draws too much current for too long and the windings inside the motor start to overheat. An overload relay measures that current over time and trips the circuit before the motor burns up. Think of it like this. The circuit breaker is a smoke alarm. It reacts to a crisis instantly. The overload relay is a thermostat. It monitors conditions over time and acts before damage occurs. The overload relay has a normally closed contact wired in series with your control circuit, exactly like we saw in episode 2. When it trips, that contact opens and the motor stops. Most overload relays require a manual reset button to be pushed before the motor can start again. Number 3, the 24-volt DC power supply. Beginners always ask, if we already have 120-volt or 480-volt AC power coming into the panel, why do we need another power supply inside the panel? Here's why. The control circuit, your push buttons, indicator lights, PLC inputs, relays, and safety devices, all run on low-voltage DC power, typically 24 volts DC. Running your control circuit on 24 volts DC instead of 120 volts. AC makes it safer for operators and technicians to work around, easier to troubleshoot, and more compatible with modern PLCs and sensors. So inside a typical panel, you have 2 separate worlds. The power circuit, running on high-voltage AC, controls the motor through the contactor, and the control circuit, running on 24 volts DC, controls everything else. The 24-volt DC power supply is what creates that low-voltage control world from the incoming AC power. Number 4, the PLC programmable logic controller. This one intimidates a lot of beginners, but it's actually a very straightforward concept. A PLC is basically a small industrial computer that reads inputs and controls outputs based on a program. Inputs are signals coming into the PLC, things like push buttons, sensors, limit switches, and temperature readings. Outputs are signals going out of the PLC, things like turning on a motor contactor, activating a solenoid valve, or turning on an indicator light. The program inside the PLC is the logic that decides what happens. For example, if the start button input is on and the safety door input is closed, then turn on the motor output. That logic lives inside the PLC and runs continuously hundreds of times per second. Before PLCs existed, all of that logic was done with hundreds of individual relays wired together. A PLC replaces all of those relays with a single programmable device that can be reprogrammed without rewiring anything. That's why PLCs revolutionized industrial automation. Number 5. Terminal blocks. These look deceptively simple, but beginners often don't understand why they exist. Here's the reason. Inside a control panel, you have two types of wiring. Internal wiring, wires that connect components inside the panel to each other, and field wiring, wires that come from outside the panel, from sensors, motors, switches, and other devices in the field. You never connect field wiring directly to a component inside the panel. Instead, all field wiring terminates at terminal blocks, rows of screw connection points mounted on a DIN rail. From the terminal blocks, internal wiring connects to the actual components. Why does this matter? Because it makes the panel much easier to wire, test, troubleshoot, and modify. Every field wire has a numbered terminal. If something goes wrong in the field, you can disconnect just that wire at the terminal block without touching anything else inside the panel. If you need to replace a component, you disconnect the internal wires at the terminal block, swap the component, and reconnect. Clean, organized, and professional. Terminal blocks are one of those things that seem unnecessary until you've tried to troubleshoot a panel without them. Let's recap what you learned today. A contactor controls large loads like motors. A relay controls small loads like control circuits. An overload relay protects the motor from overheating, separate from the circuit breaker which protects the wiring. The 24-volt DC power supply creates a safe low-voltage control world inside the panel. The PLC is a programmable industrial computer that replaces banks of relays with flexible, reprogrammable logic. And terminal blocks are the organized connection points between field wiring and internal panel wiring. These 5 components show up in virtually every industrial control panel you will ever work on. Understanding them puts you ahead of most beginners walking into this field. In the next video, we're going to start talking about how panels are designed from scratch, starting with reading a specification and building your first bill of materials. If this video helped you, hit subscribe and leave a comment below telling me which component confused you the most. I read every comment. I'll see you in the next one.